This video will cover how to run the Mojo 3D printer at the Fayetteville Free Library. The Mojo 3D printer is a business class 3D printer that can print to 0.17 millimeter thickness. That's 170 micron layers. That's a little better than the MakerBots. The other advantage here is that you're printing with ABS plastic. It's called ABS Plus. And ABS Plus is a production grade thermoplastic. Unlike the MakerBots that we have in the Fab Lab, this 3D printer utilizes two different materials. Here you have your ABS P430, and here you have what's called SR30 soluble support material. So that makes it so that this machine can run with two spools of plastic. One being soluble support, meaning that we could wash away the support columns, and then your modeling material, which would be production grade ABS. The Mojo keeps its material in what's called print engines. Print engines include both the spool of material, in this case soluble support material, as well as feeding through this tube its own guide tube and its own extruder. These would be changed out by the Fab Lab attendant or staff member. What's nice about this is that you're being provided with a clean extruder every new roll that you place in here. It's important to keep in mind that the Mojo does have a smaller build volume. This volume in here can be printed from it's a 5-inch by 5-inch by 5-inch cube. With the unit printing in ABS, there is a concern for warping. To counter that, the Mojo will heat up this interior space to over 100 degrees Celsius. Another way it tries to prevent warping is the disposable build plates that you purchase for $3. This build plate is only used once and gets placed into the Mojo and snapped in. These build plates can be purchased from the Fab Lab staff member after you watch this video, and a note is put onto your library card that you are Mojo trained. These are for $3 and they are one-time use only. Take a look at what products would look like printed from the Mojo. These two items here, the one on the left and the right, were both printed on the Mojo. The one on the right still has the support material on and around the ABS structure internally. If we were to put this into what's called the WaveWash, so everything that has support material would need to be processed into what's called the WaveWash. This is a solution in here that gets heated up. For 8 hours it's going to spin around and clean off your material or your support material from your part. So this is what it looks like coming out. This is what it would look like once it's done. We've paused this print while it was still running to show you that inside we can control the infill, but it's not as much of a control that you have in the MakerBots. In the MakerBots you can control that percentage from 0 to 100. Here it's literally just sparse or completely full. Where the MakerBots are measured in grams, here we are looking for cubic inches of material. And with that being said, we're charging $6 per cubic inch of material. This Mojo Man, as they call it, would cost $13.56 to make. One additional cost would be the disposable build platform. That would be an additional $3, making this part, eventually that would look like this, a total of $16.56. Mojos will be available via reservation. That's one reservation per day per machine. With two being in the Fab Lab, 2 patrons can utilize these each day. The Mojos do take a longer time to print, as the parts are going to be fully engulfed in support materials. So one print will typically take up most of the day. Because of the added cost with the Mojo, print failures due to model errors will be charged to the patron's account. So it's recommended that patrons print their models at least once with success on a MakerBot. setting up the machine is very easy. There's only two icons that we need to concern ourselves with. One, the Mojo control panel, and two, the print wizard. You'll notice on this computer that we don't have makerware. We don't utilize makerware for this printer. Instead, you'll want to carry over your STL onto a flash drive and plug it into the computer. From here, what you'll do is click on Print Wizard. A dialog box will open up, and that'll request for you to find your file, your STL file, and select it. Here's the Print Wizard screen. What you're looking at here is the top left here is the pending start status. That means that the machine is currently not available for printing because the door is open. Along the top, you'll see some support material. There's Smart, there's Basic, and Surround. Surround would use the most support material, the SR30. This one here is kind of a medium usage of support material, and Smart will try to strategically place the support material where needed. You can also change the part interior, in this case either completely solid or sparse, low density. Slice height is going to be listed in inches here. You can convert that back to metric, and there you see that 1.7 millimeter layer height. The STL that we had opened is now being previewed into the build plate area. You can see it's much more simplistic, this user interface, where the only option really is to orient the part, and here it provides you the different orientations. One thing to be mindful of is that this printer can print this file in any configuration, including ways that you would normally not want to print with. It would use support material all under any horizontal structure that would need it. So, that being said, orientation still is important in terms of cost of your final product, with limiting the amount of support material needed. We could also see that there's a scale, how big the part would print. And this is a 1.0 scale, so 2.0 would essentially double the size, and 0.5 would be half as big. You can adjust how many copies you make, and you can see that it will arrange them in the build volume for you. We can't click and drag to move the parts. The system will automatically arrange the parts within the build volume. You'll want to make sure that you check how you want to create supports, Smart, Basic, or Surround. In this case, we want to keep with Smart. That's why it's defaulted. We also want to check our part interior, solid. We'll actually go to sparse in this case to cut down on costs and print time. When ready, press that print button. Your part will now be processed and sliced just like in Makerware, but instead it'll be a file just for the Mojo. When completed, you'll see a build estimate of time, 1 hour 14 minutes, model material used, and support material used. When ready, click Close. Now, you'll want to bring that file over to what's called the Mojo control panel. By double-clicking on this, we can see that here's our system, the remaining model material, the remaining support material, and then the file that we want to print. But this isn't ours. If we go down to Select Part, we can go and look through a list and find the bottle that we just sliced. So there's our part. Look, we can see that estimated print time is 1 hour 14 minutes. Our model material is going to be 0.62 cubic inches, and our support material is 0.06 cubic inches. So what we could do now, knowing what the cost is per cubic inch, we can add those totals. So our first being 0.62 plus 0.06 cubic inches of support material comes out to 0.68. Now we can multiply this by 6. So we're looking at a completed part that would cost $4.08 in plastic, and of course adding the disposable build plate of $3, making the total part $7.08. So the next thing you'll want to do is to go and purchase your build plate, and here it is. This build plate needs to be snapped in place. There are tabs on the bottom of the build plate that align with holes in the aluminum gantry. Place those in, and then by pushing on the front, push until you click it in. You'll hear a snap. I'll do that again. So push until you hear the snap. These blue containers store the leftover, the excess plastic that's dripping out of the nozzle. It constantly cleans itself layer to layer, so your print will come out very clean. When that's snapped in, we'll lift up the door and our light should turn green. Steady green status, we're ready to print. We have remaining model material and remaining support material. If we were to run out of one of these materials, the system would notify us here. With our preview here, we could go and press print. Don't be alarmed at the amount of time that it takes the machine to warm up. This has been accounted for in the estimated completion time. So you will get an accurate completion time, but it does take some time to start up. What it's doing is internally, it's heating up this area to over 100 degrees Celsius. It also will need to make sure that the plate is level, and it will do that in a series of 9 to 12 different points. While the machine is warming up and processing your part, this would be a good time to fill out the Mojo pickup form. What you'll want to do is fill out your name and phone number, as well as the material, both model and support material listed, and file that with the staff member on desk. When your part is finished printing, we will go and place it into the WaveWash system. The WaveWash runs for a series of 8 hours, making it so that your part-time turnaround will have to be 2 days. 1 day to print, 1 day to wash, and the next day to pick up. And those would be business days. The system just gets turned on, heats up the solution, and spins it and agitates it to wash away any support material that you have, so you're left with just your ABS material.